Hi everyone, welcome to Math. Today we are going to study chapter 6 triangles, exercise 6.2 question 7. Using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. I'll first explain to you this with the drawing the diagram. So what we have to draw is a triangle. How we have to draw? Prove that. By the way, using the theorem 6.1 is what? Basic proportionality theorem. Exercise 6.2, I have explained to you theorem 6.1, that is basic proportionality theorem. What is that theorem? I'll just revise it. The theorem says that if you have a triangle ABC and then any one side of the triangle, if you draw another line which is parallel to that line, EF, let's take. So if you are drawing a line parallel to one side of the triangle, then this line will intersect both the side into equal ratio. Meaning to say that EF, if it is parallel to BC, then AE upon EB will be equal to AF upon FC. Okay, so this we call it basic proportionality theorem. That is 6.1, theorem 6.1. Okay, so if lines are parallel, then the ratios are equal. So that's all. That is using the theorem 6.1. What we have to do is, we have to prove that line drawn through midpoint of one side of a triangle parallel to another side bisects third side. Okay, so let me first draw a triangle, then I'll explain to you. Let's consider this is a triangle ABC. Okay, so now prove that a line drawn through the midpoint of one side. So any one side we will take the midpoint. So I'll take here. So let's consider this is the midpoint of one side of the triangle. Okay, I'll name it D. Okay, so this is the midpoint we have taken, right? Midpoint of this side, one side of the triangle. So midpoint of one side of a triangle parallel to another side. So we have to draw a line. See, we have to prove that a line drawn, okay, drawn through the midpoint of one side. So we have to draw a line. Midpoint of one side of a triangle parallel to another side. So we have to draw a line parallel to another side. So consider this is side 1, this is side 2, and this is side 3. Okay, just for you to understand. So now what we are doing, so midpoint of one side, first side will take one side of a triangle parallel to another side. So we'll have to draw a line parallel to another side. So second side, for the second side, so we'll draw parallel line. Okay, parallel to another side. So this line is parallel to the second side. So we have taken the first side, the midpoint, and then draw a line which is parallel to the second side. Okay, now this line will intersect or parallel to another side bisects the third side. So this line will bisect the third side, means divide this line into two equal parts. So let's consider this is point E. Is it clear to you? So prove that line drawn, we are drawing a line taking the midpoint of one side of the triangle. We take the midpoint and draw a line parallel to the second side, and that line will bisect the third side. See, bisects the third side. So this will bisect the third side. Is it clear? Okay, so what we have to prove? We have to prove that this line is through the midpoint of one side of this other side bisects the third side. That means we have to prove that this line is bisecting the third side. So what is given to us is, so what is given to us? Given to us is, first what is this? Midpoint of one side. We have taken the midpoint of one side. If this is midpoint, that means this part will be equal to this side. So that means AD should be equal to DB. Because it is said no, taking midpoint of one side. Midpoint of one side we have taken. That means this is two sides will be equal. Then one side of a triangle parallel to another side. So that means this is parallel to this side we have drawn. So DE is parallel to BC. Okay. So now what we have to prove is that this line is bisecting the other side. Bisecting means equally dividing the other side. So that means to prove, what we have to prove is AE is equal to EC. This side, this line is bisecting the third side. That means AE is equal to EC. That's what we have to prove. Okay. So let's start the proof. Okay. So let's take triangle ABC. In triangle ABC, we have, so in triangle ABC, what we have? We have DE is parallel to BC. DE is parallel to BC. So therefore, by basic proportionality theorem, I told you here, basic proportionality theorem is what? When line is parallel, the other two sides ratios will be equal. So what is given to us is DE is parallel to BC. See, DE is parallel to BC means this ratio will be equal. So let's write down. Therefore, AD upon DB will be equal to AE upon EC. Let's consider this as equation 1. So now what is given to us is, we have given one more point. What is that? AD is equal to DB. AD is equal to DB. Okay. So therefore, if you consider equation 2, therefore from equation 1 and 2 we have, okay, from 1 and 2 we can write this AD instead of DB. Can we write AD? Because DB is equal to AD. So let's write down this. AD upon, instead of DB we'll write AD equal to AE upon EC. Okay. So now both side AD. So if we cut, we get 1 equal to AE upon EC. Now cross multiply. So when we cross multiply, this is in division. When it comes here, it will go to multiplication. So AE. So hence, you see what we have to prove is AE is equal to EC. AE is equal to EC. So that's what we are supposed to prove. Hence, E becomes the midpoint of, see, if E becomes midpoint, then only AE will be equal to EC. So midpoint of AC. Therefore, AE is equal to EC. Answer, or you can write hence proved. Okay, hence proved. Okay, that's it. Thank you and God bless.